Hi, good afternoon, everyone. So, yeah, I'm David, engineer lead at Cowrywise. Please ignore what he said. He just read my LinkedIn bio. It's not that deep. So, yeah, so my talk today is centered on observability. So, basically, what we'll be covering are the three pillars of observability, the MTT star metrics, use cases, and then best practices. Right? So back to the second slide. It's a culture and a practice. And what this means is that it's something that has to be part of your engineering process. It's not an afterthought, right? And then it's something that you need to continuously keep improving on. You don't just set up logs once and then yeah, it's done. It's something that you need to check, optimize for, all that stuff, right? So the first part is the three pillars of observability. Yeah, so this is basically the first answer on Google, right? Observability is how you can understand the condition of a system based on just its outputs. And these outputs are in related to observability. Those are logs, metrics, and traces, right? So it relies on these three to give a complete picture of what's going on in the system, right? So most people are used to just logs, right? Logs will give you, okay, requests, database calls, all of that stuff. But then there are some things that you will not get from logs. You might not get how much CPU usage the the application is using. May not get what the latency is from logs. Well, you can if you configure your login format well, but you might not get things like memory usage and all of that. And that's why you need to integrate all three: logs, metrics, and traces. So logs are basically a text output from your application, right? It can contain it can contain timestamps, it can contain messages, it can contain the user that is accessing the application, tons of things like that, depending on how you format these logs. There are logging levels, right? So for some third-party libraries, for something like, are there Python developers here? Python. No. Okay, fantastic. I have some Python guys here, right? So in Python, some libraries configure login, right? They can configure login, they can configure debug login, they can configure information, they can configure warning. So based on what your logger consumer is listening for, it would log those things to the output, right? So that is what we are referring to in log levels. Um, Effective management of logs include rotation and retention. So there's one problem that we used to face early on in the company, and it was that our logs kept getting our boxes full, and this was because we were always trying to maintain logs of last 2 years, 3 years, stuff like that. So what happens now is that we push these logs to a log server, to Elasticsearch, and then we delete them. So basically, the logs are retained on the server itself for like 30 days ish, for whatever reason, that in case it doesn't get pushed to Elastic. And then there's rotation. So after every 30 days, it compresses the logs and then stores it somewhere else. Logs are really good for debugging and troubleshooting, right? It's the first thing people say, oh, server is crashing, check the logs. Like that's you know. Um, and this is, but anyhow. So the last one actually was meant to be unstructured logging. So you can have logging in plain text, something like this, right? Which just shows it shows the timestamp, what is generating the logs, and then the log message itself, right? And then you can have something like this, which is, I don't know if you can see this. Can I zoom in? Wait, how clear is it? Okay, so you can have something like this, which shows a bit more detail, right? So if you have, let's say, 10 services, right, across your infrastructure, you can configure a standard login format for them. And what happens is that you would have things like the IP address, the service name, all of that stuff. And then you can now do log correlation. And which is actually getting into the next part of the pillars of observability. The next, okay, the third one anyway. So the next one is metrics, right? So it's logs, metrics, and traces. The next one is metrics. Metrics are they're usually numerical values that give the performance of it, or that give characteristics of a system, right? So metrics can be your CPU usage, it can be your latency, it can be what else? Memory usage, it can be error rates. There's a ton of things that you can define as metrics, right? You can visualize these metrics with APM visualization tools. There are a bunch of them. Sentry has one, Elastic has one, New Relic. There are a ton of tools. There's Grafana, Prometheus, all of that stuff. So metrics provide real-time data and insights on how real-time and historical data on performance, right? So you can see things like how has been the CPU usage over the last 3 months, how has it been over the last 1 year, and you can get the average and then use that to make decisions. Um, yeah, so these are a list of, I talked about this already, error rates, request throughput, latency, queue length, a ton of stuff. And then the last one, which is my personal favorite, and I think is the most important, which is traces. Right. So traces show a detailed part of the transaction throughout the system. Right. So assuming you have a system that does HTTP calls, that makes database calls, that accesses a cache, well, that or you have let me see, and you have a MongoDB instance, all of that stuff, right? So during that process, a lot of things happen. We might do a database call to fetch the plan that user is saving money into. We can use MongoDB to get maybe some cache details of the user. We would make an API call to Paystack or Flutterwave or whichever is handling that. So the trace would show a detailed timeline of everything that is happening at every point. And even best when you have multiple services calling each other. So what the trace does is that it tells you that, okay, this your service entered your second service and it did this bunch of things. I would show you what that looks like on one of our own instances. But then this is, I hope you can see this. So this shows two services, a .NET service and a Node service. So the .NET service is the blue one, right? Yeah, it's the blue one, and the Node service is the green one. So it shows that, oh, the request entered the Node service, went to the .NET service, did a bunch of database queries. What else did he do? Yeah, that's pretty much it. So with this, you can have a full picture of the transaction itself, and then you can know where something breaks, right? So now back to this part. So the evolution of architecture of software application generally has, so it's been interesting over the years, right? We all started with monoliths. It was just your one application, your HTML code was inside, backend logic, everything was all contained. And then we moved to NT applications, which is, you have the front end for presentation, you have your data layer somewhere else, maybe S3 or whatever, and then you have your application logic separate. And then we moved to SOA, service-oriented architecture, right, where you have your main code base or your main application, and then it interacts with a bunch of either um, a bunch of other like little services over API calls or gRPC or whatever you choose to implement it with, right? But then the main entry point is still your main application, right? That was the SOA architecture. And then we moved to microservices where everything is now separated. So the difference between the SOA and microservices is that, let's give an example. Yeah, saving money, right? So in the SOA architecture, um, your main code base will be the entry point. Your main application will be the entry point to every other request. So if a user is making a request to save money or to fetch a plan, everything goes to the main code, and then the main code calls whichever service it needs to fetch it. In microservices, it's a bit different, right? Microservices, you have the saving money service or payment service or whatever, and then you have user detail service or all of that stuff. So the entry points are different now instead of having just one with the SO architecture. Now, the reason I'm explaining this is that I want to show something. Okay, so this is um, within our own app. So when you are making a transfer, right, it goes is an SO architecture. It enters the main code base. These are a bunch of spans saying what is happening at what time, right? It has all of this going on, database calls, right? And then you see that there is what's going on. Okay. Yeah. So there is a call to a background task. We have this log here. There is a call to SES to send an email. We have this log here. There is also a call to another service, which is down here, right? So we can trace the full part of the transaction. So if it's failed at the disbursement service, we know where to pick it up from. If it failed at the background task, we know where to pick it up from. And that's the beauty of traces, right? Now back to this. Yeah, traces make sense when you visualize them. So let's look at a real life scenario on why observability is important. So this was sometime in 2021, right? Um, we pushed the hotfix to master. So what that means is that it doesn't bother running CI tests or all of that stuff. So our hotfixes are usually maybe an update to an error message or a change in the content of an email template, things like that. Things that are not breaking changes, right? So we push the hotfix to production. So around like 10 in the morning or like 11, peak periods, yeah, push on production. And then out of nowhere, production was crashing, but for certain users. Now, this is the context. We have two types of authentication on our on our core app. We have the JWT authentication, and then we have the OAuth authentication. So something happened that the maintenance the um, of the JWT library that we use pushed. Okay, so the maintenance of the JWT library that we use, they did not pin a particular requirement. So what happened was that when we updated the library, it also updated a particular requirement. And in that library that we use, the function called change, like how it was usually called, was not the same anymore. So it turned out that for users that were authenticating via JWT, it was crashing for them. And so the first what's the word? The first instinct when we have a crash with a hotfix is just to revert, right? But the problem with reverting is that with us reverting that commit was that it wasn't the code that was causing it; it was a requirement update. So once we reverted the commit, it didn't really change anything because it still built and installed the old dependencies, which was like the main issue. So then we got to look at logs, um, we got to look at the logs, we looked at the traces, then we realized that, oh, it's just people that are making requests via the GWT, just people that are logging in via the GWT service that are having this issue. And then we could pin that down, right? Which is the beauty of having traces and logs. Now, once you have observability implemented, the next thing is to know how well you are doing with this implementation, right? You have your logs, your traces, all of that stuff. And then you want to know, okay, how well is this thing working? Or how well can we respond to incidences? And that is where the MTT star metrics come from. So different people or different schools of thought have different versions of this. So some people would have, so this is MTBF, mean time between failures, MTTR, mean time to respond, MTTA, mean time to acknowledge, MTTF, mean time to failure. Some people have other versions like MTTD, mean time to detect, right? So it depends on what you want to really monitor for your own team. But then this is pretty much the basic ones that exist. So mean time between failures. Okay. Yeah, so mean time between failures is the average time between system failures, basically. Mean time to repair is the time it takes you to repair after a failure. MTTA is mean time to acknowledge that there was an incident. And mean time to failure, MTTF, is the average time it takes for a system to encounter an unrecoverable failure, right? So looking at this, can we like pick out what's the mean time to acknowledge, what's the mean time to repair? What is the mean time between failures? So for a hint, this is the first one. So mean time to acknowledge is the time between when the alert comes up on your error monitoring tool and then an engineer responds to it. So at this point, this is when the alert is triggered, and then this is when the alert is acknowledged. So this is your mean time to acknowledge. This is your MTTA. Now, mean time to repair is the time between when the error first comes up and after the service comes back up. So your mean time to repair could be between what is it? Yeah. So your mean time to repair can be between here and here, or when the alert triggers and this part, depending on how you choose to measure on your team. Then there is what's the other one? Mean time to failure. So we don't have this on this chart. Mean time to failure is when there's an unrecoverable failure, meaning that like the system just went down like completely, basically. So after all of this, after all of the whole talk on observability, there are some people that are doing some really crazy stuff with observability on their own teams, and I think is worth talking about. So the first people or the first team is Netflix. So there's something called chaos engineering, and they were or they are one of the first pioneers of this ideology. So what chaos engineering does is that you intentionally cause a failure in your system to see how well your system responds to it, just to see how well the system is going to respond to it. And then they can only do things like this because they have like observability set up. They can monitor that, okay, yes, this went down, this happened, this recovered, stuff like that. Um, Elastic, which is the tool that we use in-house, they have this ML tool, right, which they use to predict when next your system is likely to go down. So what happens is that it looks at or it just predicts when there's an anomaly in your system. So it looks at the bunch of your logs, your traces, and your metrics, right? And then it uses that to predict that, oh, on Friday at this time, you don't usually get this much traffic. There's something might be wrong here. Or your latency on this endpoint is usually not this high. Like something might be wrong here. So that's what they do with ML. And it is very interesting how it works because sometimes you will see the alert and you're like, nothing's going on. And like until your service now goes and you're like, oh, they were right. Like, um, yeah, so yeah, the ML models in Elastic can be trained on data from historical periods to improve their accuracy and help predict future anomalies more effectively. So now, so this is the last part. Yeah, the best practices for setting up observability in your stack or for your team. So first, choose the right tools. So in the real sense, you might think there is no right tool, but we've come to realize that it's usually better when um, the stack that handles your logs is the same one that handles your metrics and handles your traces. So some tools don't offer that. For example, I think Prometheus doesn't show you logs; it only shows you metrics. It doesn't show you traces either. Datadog, Datadog shows logs and traces. It shows all. Oh, really? That's deep. Well, yeah, but at the time I was looking for implementation, that I didn't find that I didn't find one on Datadog. I'm not sure which one it was. But then Elastic offers the whole three. It offers tracing, metrics, logs, all of that. New Relic does not have logs. It has traces and it has metrics. Sentry does not. Does Sentry have logs? I can't remember for Sentry. But then different tools have their use cases, right? If your team, better works better with having different tools for different things, that's fine. If your team wants to have one central place for traces, metrics, and logs, then you should consider one of these other ones. Then define clear metrics for your dashboards. So the default ones are yeah, so the default ones or the standard ones, CPU usage, memory usage, what else? Latency, RAM, disk space, all of that stuff. But then for your own particular use case, there might be some things that you'd want to define. So for example, maybe the average database call time. That is something that you want to define, or the number of database calls per span. That's another thing that you might want to define. So depending on your use case, you define clear metrics for the dashboards. Leverage automated alerting, which is very important, right? So I'll talk about my team a lot because we sort of have this set up already. So we have two different alerts. We have one for server alerts. So when you have a full disk, when you have a what else? When you have high CPU usage, we have an alert for those ones. And then we have error alerts, so application alerts too. So they go to different places. So alerts for CPU usage and all of that, it goes to your SMS because yeah, something is wrong. Go and check it out like ASAP. But error alerts go to Slack, and then you can just make sure you leverage automatic alerting because it's always very useful, especially if maybe the tool that you use doesn't have automated alerting. You can set that up yourself. It will help when you're doing things with when you start tracking this metric, the MTT star metrics, for when the alert was triggered, when the developer responded, all of that. Um, yeah, incorporate observability into the um, development process. So what this means is that, yeah, like I said in the beginning, it should be a culture. So once you are writing your code, you should put the laws necessary in the right places. You should add transaction spans. So this, for example, right? So most tracing tools would give you they would name some spans for you, right? That's what I mean. Most tracing tools will name some spans for you, but some others would not. So, for example, these spans were created by us. This is our service code within the application. So these spans were created by us. Usually, Elastic will not trace your service code for you. It will only trace the database calls and the API calls. So what happens is that you won't see this. You will just see this entry point, and then you see a bunch of database calls that follow at the bottom, right? So this might not be very helpful. 8 large database, which is like a 64 gig or 32 gig RAM. What else? A bunch of like really, really high specs, right? So if you are checking things like your CPU usage and stuff on that database instance, it's going to be low because there might not be so much going on. And if you're mentioning just metrics, it will seem like you're doing a good job. But if you now measure something like the um, database, something like the, the select, what was it called? If you start measuring something like the time it takes to return a response from database, right? It might be something like 5, 10 seconds, but then it won't really matter to your database type because what's it called? Your configuration for the service is really high, right? So you should measure across the infrastructure, across the application as well, and across the network. So finally, continuously refine and improvise, which is very important. You might set up, so for example, the custom spans that we implemented came up way later, like 6 months after we implemented APM. And that's because we realized that, oh, this thing isn't grouping database spans the way we wanted to group them. So you have to continuously improve on your setup, refine, change, add new data points, remove data points, whatever you need to make it work well. And that is pretty much the end of my talk. Thank you for listening.
Defining clear metrics. So I wanted to ask that you guys are fintech, so are there some other things that I'm talking Cowrywise now? Are there some other metrics that you guys collect that is not, it's not maybe for compliance purpose or for security purpose that is not really general, like that? Can you name some of them? And then the second question is about how you guys alert yourself about how that some goes to Slack, some goes to SMS. I'm guessing IRAs, LRS, or something like that. But what about for cases of service degradation, where there's no failure, or something is just being processed, maybe needs is processing, transfer slowly or anything? How do you guys get alerts for things like that?
Okay. Yes. So you had two questions. The second one was on how we get the alerts, right? And the first one was Yeah. Um, so I won't say they are extra metrics. It's just that we use the current data that we have on Elastic to create other things. For example, we have third-party providers. We use VFD, we use Okra, right? And then at the end of the day, we want to know how well this API is working. How many failures do we have from BVN? How many failures do we have from Okra? And what are the response times? How many API calls we make in a month? So we collect that. We can analyze that as well. But on the user level, so one thing we do is that on our observability stack, right? You can see the list of users that have logged into the application, and then you can see the IP address that they have logged into, right? So this especially helps when someone's account gets hacked, and this happens way more than you think. Users can be very careless, so their email will get hacked, and the person would use that to change their password and all of that stuff and get this access to your carrier's account. So what we try to do is that we try to see the person that logged into this account from this IP address, have they also logged into other accounts? And then we can use that to alert the user that, oh, your account details might have been compromised, please update and stuff like that. So it's not like we collect anything extra per se for our metrics. We just use the current data that you have and make out better dashboards from them. Then for the second one, so our application logs error messages straight to Slack, right? So we use our core backend is written in Python, it's Django, right? So we can intercept the exception and the exception message and then post it to Slack. That's what we currently use for application error messages. For server downtime and all of that, we use CloudWatch. So there is how do I explain this? So there is kind of a Lambda function that checks the statuses of different boxes. So it does a status check on our core boxes, application servers, database servers, what else? Microservices server, right? It does status checks on them. And then once it experiences a degradation, it sends a message via SMS. So for things like nibs, right? So we have a Slack channel with Flutterwave, with who else? With Flutterwave, Paystack. I think it's a general thing. We had a Slack channel, and then they have a Slack bot or something that updates us. So when they have a downtime on their own service, we get that Slack notification. So we're kind of relying on them to give us that status update. That's just for us to like know. But then we have a service. So we have a disbursement service. So disbursement service basically it's to help with withdrawals, right? Because we use multiple providers like Paystack, Monify, different people. We want to know that, oh, if Paystack is down, let it automatically switch to the next available provider. So we use their status pages, the API. We sort of crawl the URL to get if it's down or not, and then we notify and then change the provider. So that's how we do the updates. Good. Thank you.
Thank you very much. Next question. Visualizing the Look at the numbers.
Yeah, thank you so much for that wonderful presentation. Now, my question is this. Let me create a scenario that I have my front end and my back end application. And this back end application is running in my class.
Okay.
And I have my Docker Compose YAML file. It is. So how am I going to integrate the tracing probably I want to measure metrics on that application? Is it to integrate on that app or probably come to my YAML file, build the service there?
Okay.
Thank you.
Yes, so for tracing is an application thing, right? So you have to implement the tracing on the Flask app itself. You get the particular service you're using, get their Flask or Python library for it, and then implement on the app. But then it also depends on how your service is running, right? So for example, if you are using something like traffic, right? That's Traefik, right? So traffic also provides tracing. So you can add um, your tracing config to traffic itself and then to trace throughout the whole service. So it really depends on how it's being deployed. But tracing is usually an application thing. So you have to implement it on your app itself, the Flask app or Fast API app. Yeah.
Thank you very much. Is there someone to contact us also? That's
Okay, so thank you for the presentation.
Thank
My
you.
question is about logs, right? Logs they are both sensitive insight about the application, right? How do you manage logs between environments? What would you recommend? Because sometimes you could have logs on dev and you don't want to prod or stage, right? What option do you recommend?
Okay. Okay. So usually, where you would ship your logs to, um, would have like a namespace. We have like some namespace in settings, right? So for example, on Elasticsearch, you can create indexes. So we ship all our production logs to core app dash production namespace. We ship all the staging logs to core app dash staging namespace, right? So when we are searching, we can search all the logs like both staging and production, but then we can search for under just production and under just staging. Same thing applies to different services. You can create a namespace for an index, or it's called indexes in Elasticsearch. You can create an index for your payment service, create another index for development service, things like that. So you probably have to have like an environment variable or something under different environments. You should ship it to this place or ship it to this place. Okay, guys.
Thank you. Number four. Um, good afternoon. Thank you for your presentation. My name is I'm just going to the experience. What I get experience about giving it application for that's the So, based on your topic observation, you actually mentioned a lot, the traces and missing one right now.
Mhm.
I've actually seen everything in practice. Talking about the traces using S3, it was S3 traces. So we actually worked on a project called image optimization basically. So it uses so many standard functions, storage devices, etc., NSS and all that. So I was able to see all this in practice. So now, I have a question, which is in practice, if I wasn't doing LLMs or EFS, I don't know about all these stuff. As a DevOps engineer, we don't have to pay much attention to it. All to do is just pipeline production and that's all. So, what do you suggest as per we want to practice about all this? Because it's actually costing. You have to put in so many tools together. I wasn't working with you or working with the organization, and obviously not. So, what we advise in terms of learning on all these that you just mentioned, especially the traces. The logs are used to it, but the traces actually have to be involved with so many API calls, so many databases and all that. So that's my one question. But question you talk about chaos engineering or chaos working for epic track. So now that is being used for what do you call this? EC2 instance. For example, you have so many EC2 instances and you use a lot of functions, target one and shut it down. Or in a situation whereby you're using EC2 instance, you're using quantities, and you have this many calls and how do you test that? Because you already have a limit. I can't share that one on one, I can't share that one on two. So you automatically do everything for you. So how do you do that in terms of testing your faults, in terms of qualities and all? And lastly, sorry, if my question is so lastly, yeah, I noticed we trying to get an opportunity in outside country because I think Nigeria don't really have much to the need as a level. It's not really common in most startups. Let me just put that. It's not common in startups. And we're looking for opportunity after learning, want to learn more, want to get experience. So in somewhere like a company, how do we apply to work as an intern? We want to be paid. We just want to learn. So how do we apply to work and get thank you very much.
Okay. Yeah. So the thing is, so with your first question, it's hard to answer because I'm not exactly sure what the question was. But then, if you are asking about how, um, what, honestly, can you clarify that first question again?
How do you learn all this?
Okay.
Because learning from that system and all that, they have a chance to they have a they have a subscription for us to use to test.
Okay.
So we can have others for that practice. So how do you use all these things to learn? Because I remember I was time I learned another project was
How do you learn? And I'll be very honest with you here. So I did not also learn about. I didn't just learn about tracing. I didn't just stumble like I didn't just like, oh, let me learn tracing today. It's kind of happened as a necessity, right? We realized that, oh, we had some things going wrong that we could not like pinpoint, and that's why it brought up the need to, oh, implement tracing and metrics and all these things, right? If you are building a small project, chances are you would not even think about implementing tracing. You have logs, yeah, everybody will put logs, but then metrics and tracing is like an afterthought. But then, as soon as you start reaching scale, you start thinking that, oh, we need to optimize X endpoint, we need to like make this one run faster, things like that. So what you can do is that just learn how these tools work, like learn how to implement them on your own projects, right? But then that you would, sit down one day and say, okay, I'm learning metrics throughout this week or something. It might not really work that way. Just know that, oh, this exists, know how to implement it. Because most are really just plug and play. It's like you copy and paste configuration and it's working, right? For most of them. So yeah, just sort of learn it. I don't know how you learn it. Just learn it. But most times it comes up as a means of necessity, not that it's a requirement per se, right? Then the second question, this who can remind me. No, that's the third question. That's the third question. Apply square is the third question. The second question. Oh yeah, for yeah, yes. So I've not really worked with Chaos Monkey for Kubernetes or Chaos Monkey that extensively to give recommendations on it, right? I just know about this one for EC2 instances and the Simian Army for a bunch of other things. So for Kubernetes pods and all that stuff, right? You might have to do research on it. I can't give an answer right now, but I know it should exist somehow, right? Just sort of do some research on it. Then,
Ryan matters, how does it get the job? Please.
yeah. So I can't make any promises about this, right? But like usually, just shoot your shot. So we have an email, people@cowrywise.com. Just shoot your shot. And then I think like 3 people or 4 people have gotten in like that, right? So just shoot your shot. If you're lucky, like they like and they respond to you. That's what I can say, to be honest. Shoot your shot, send your CV, introduce yourself, and we'll see.
Thank you very much, Jay. Last question.
Okay, thank you much. Thank you so much for the presentation. I just have two worries, which are the questions. Very simple question. One, about cost.
Okay.
There's always a large amount of data to analyze and also to use to find the metrics around this. For a small organization who's like client, they have a very small limited budget. I don't think that you can be able to fix into the
Okay.
question one.
Okay.
Question two, legacy system.
Okay.
For instance, you look at our financial banks like GT Bank, for instance. They have not adopted anything like observability because observability itself it wasn't even at that time when they were implementing it. But I tell you, this thing is going to be very funny.
Okay.
For those legacy systems that's already on ground, like the GT Bank application that's already there, how can you be able to with that kind of a system that is being just lying down there. How can you be able to bring in into incorporate that
Yeah.
observability inside it to be able to ensure that reliability of that system?
Yeah.
I'm very concerned about this too. Thank you.
Okay.
Hello, guys. Can we put that one house, please? One house, guys. One house. Chief, one house, please.
Okay. So for your first question, right, the answer is it one word or 2 words? I think it's 2 words. Open source, right? There are a bunch of open source tools that can do the same thing. That okay, so Prometheus is open source. Grafana is also open source. What? AOK. Yeah, exactly. The ALK is actually open source, but then at some point when you want to access some things, they tell you to buy a license. But then it's open source, right? These tools are open source. You can install it on your own server, implement it yourself. You don't have to use their cloud hosted version, right? So yeah, these options are available. Then the second answer to that question is startup credit. I, so there are a bunch of accelerators, a bunch of companies that offer startup credit. For example, MongoDB offered $500 startup credit. Linear offered 20K startup credit, right? So the idea is that, oh, yeah, use this tool. Once you start earning big enough money, you'll be hooked to us and you have to pay us. So some companies also offer startup credit. Portena, which is another observability tool, offered 3 years business license. 3 years. So there are a bunch of tools that there's a bunch of tools that will offer startup credit to your company. You just send some details, introduce yourself, and then they'll do that. Right. So leverage open source, leverage startup credits too. Then the second question on legacy system. Yeah. So there's a standard. I don't know if it's a standard or a thing or what to call it, but there's something called open telemetry, right? Which is pretty much what observability is, the whole observability thing is based on. So with open telemetry, it doesn't matter what stack, what language, whatever you're running on. All it knows is that it can send the specified format for metrics and logs and all of this, right? So open telemetry would work for cases that are legacy. Plus, also, I don't know how legacy a system can be that you can't install a third-party library and use on it. But then, OpenTelemetry will be your best bet for that. Yeah.
Thank you very much.
Thank you.
We want to offer for Uchenna today.